In example 3, we are told that a sports car speedometer registers 50 miles per hour as it passes a mileage marker. 4 minutes later, the car passes a marker that is 5 miles from the first. The speedometer registers 55 miles per hour. Can you use the mean value theorem to prove that the velocity of the sports car was more than 70 miles per hour at some time between the two mileage markers? All right, let's see if we can prove that the guy was speeding. Let's see. Let's get some common units going here. So we're working with speeds that are in miles per hour. So my distances are going to be in miles, my times are going to be in hours, but they give me an elapsed time here of 4 minutes. So let's do this. Let t equal the elapsed time in hours. So we'll need to do some unit conversion. After the car passes the first marker, A. Also, let's do this. So let's let S of t be our distance, since that's a position function, distance in miles from the first marker at time t. All right, so I guess the second thing I want to do is convert minutes to hours here. So we've got t equals 4 minutes times 1 hour over 60 minutes gives me 1 over 15 hours. All right, so here is a quick sketch of what's going on, at least in terms of understanding this problem. We've got 2 mile markers, A and B. Our initial time t equals 0, the elapsed time 1/15 of an hour. S of t is the function that gives our position as a function of time between these 2 points. This is the distance from A as a function of time t. So, let's do this. Let's find out what the average rate of change is. So V average is equal to S of 1/15 minus S of 0 over 1/15 minus 0. Okay, so now the question is, what is the distance traveled from S of 0 to S of 1/15? So we're told that the car traversed 5 miles. So this total distance between these mile markers is 5 miles. So that's going to be when S of 0 and here's S of 1/15, 5. On the bottom we have 1/15. And if we divide 5 by 1 over 15, we get 75 miles per hour as an average speed. Well, okay, what about the mean value theorem? Well, okay, so this is a smooth, continuous, differentiable function. His position as a function of time. At no point was he teleported from this point to that point. And so if he reached an average speed of 75 miles per hour, there has to exist a point C, a time C, when his speed was between 50 and 75, or between 55 and 75. So at least twice he hit 70 miles per hour on his way up to whatever his maximum speed was. So there exists a times t equals c, whatever that is, where velocity is equal to 70 by the mean value theorem.